Hello everyone, welcome to this session number 6 as part of the training program on Introduction to Python Programming and its applications in water resources sector. Till now we have seen the installation of Anaconda distribution along with Python and the third-party packages installation through Anaconda prompt, and then we have seen Anaconda Navigator and then the utility of the Jupyter notebooks. Later, we have seen the basics of Python, namely the basic data types, inbuilt data structures, functions, conditionals, loops, control flow in Python. And then we have seen the overview or introduction of object-oriented programming. Today, we will be seeing object-oriented programming in Python and then file and error handling in Python. And we will also try to cover some topics which we couldn't cover as part of the basics. And then in the next session, we will be starting with working with Pandas, which is a third-party package meant for analysis of tabular data. Uh, In the last session, you have seen about introduction to object-oriented programming. You have seen about the class and object, which is an instance of a class, methods associated with the class, and attributes or properties associated with any object. Um, Today we will see how the object-oriented programming is implemented in Python language. We will not get into the details of object-oriented programming, which is not our purpose, but you need to have a basic understanding because everything in Python is an object. Every time we will be saying an object has been created. Now, just as you have seen, um, um, there are basic data types like strings, integers, floats, and then there are inbuilt data structures like lists, tuples, dictionaries. You can also create user-defined data structures, which are known as classes. Object-oriented programming approach becomes useful when you have a code which is very complex with more data and functions. And obviously, when there is some way of grouping together at least the related data and the functions in a logical manner, that would be very helpful. And that utility is provided by the object-oriented programming paradigm. Classes allow user-defined data structures, and class is a blueprint for defining any object. Class doesn't hold any data as such. It is just a blueprint, or you can say a structure um, for defining any object, and any instance of an object with actual data, with actual real data, is known as any instance of the class with actual real data is known as an object. Now, and there are methods or functions which are defined inside the class, and they define the behavior and actions that an object can perform with its data. Now, to make things clear, let us consider that though list is an inbuilt data structure, let us consider it as a class. And then we have seen in the session on data structures, we have initiated list objects by defining the list by assigning values to a variable like we have defined list 1 is equal to within square brackets we have passed down the elements 1 2 3 4 5. That is that how we have initiated a list object. And then we have used list methods which were operated upon the list object. And those methods were cannot be can only be applied on the list objects. So in that way you can define any new data structure that will be a class, and we can initiate any object of the class with real data, and the objects will be having attributes or properties, and then there will be methods which will be inside this defined class, which can be operated upon the objects of the class. So that is about object-oriented programming. When we come to any creation of any new object, we will again have a look at it. Coming to error handling in Python, broadly there are three types of errors which can occur: syntax errors, runtime errors, and logic errors. Now, Python with its simple and easy to use syntax, easy to understand syntax, offers less scope for committing syntax errors. And even if anyone commits syntax error, it is very easy to identify where it is, and it is very easy to rectify. So then the runtime errors which occur during the execution of the program, they throw exception and the program comes to a halt, and in error message gets printed, and it is which offers insight into what went wrong. And reading error messages, practicing the reading of error messages and understanding its contents, it becomes very important to trace the error. And Python has no, error handling in Python is relatively easier than with many other programming languages. So when like in this error message, as you can see there, the name of the error got printed, and the details of the error are followed by the details of the error, and also a trace back on where could have been something went wrong in the program. It may not point out to the exact line. Sometimes it refers to the line where the error has occurred. It may be due to call of a function in that line or some other reason, but Python tries its best to locate where the um, error has occurred or what has led to the exception. So reading error messages becomes very important. So for a beginner, this traceback may look very confusing or scarier, but if one takes time to read the output, they will definitely they will get to use and they will find the information very helpful. So then there are that is what we said, the runtime errors can be rectified by reading error messages and looking at the traceback. Now the third type of error, which is the logic error, they are caused by the unexpected behavior. Nothing goes, the program runs as if it is perfect, but the results are not as per the expectation. That is because of some logic error that you have committed inside the code, like missing of some parenthesis or change in order of of expressions, some logical error which will be hard to find. So there are ways that unexpected behaviors are they are called bugs, and removing the bugs is known as debugging. Now debugging, Python's IDE, integrated development and learning environment, the basic IDE, it provides a debugging control window, where it is possible to identify the bug by running the code line by line. So this is about the error and exception handling. Now let us see some examples. I will first launch my uh, Jupyter notebook from Anaconda prompt. Again, it will open open and point to the present working directory. I will go to my folder where I am saving the notebooks. I will create a new notebook and I will select the kernel Python 3 IPython, and I will open my notebook in Jupyter Lab and I will rename it by saving the notebook as, I will give the relative path python wrm/notebook/ here I will name it as notebook number 4, object oriented programming, error and file handling, dot the extension IPYNB. To start with, let us see how classes which are user defined data structures are created in Python, and how the properties that are instance attributes that all objects of a class have are defined, and how to instantiate an object in a class. Classes in Python are defined using the keyword class followed by the name of the class. Let us say I am creating a class of cars, followed by a colon, and if you press enter it will automatically take the indentation, as in the case when we have seen the definition of functions are in the if and else statements. Now suppose you just want you have just decided to create the class called cars, but you just want to initiate it and leave it without having an error, without defining the body of the class. In such cases you can use the pass statement. Pass doesn't do anything, it is just a placeholder. It does nothing, but it will help in overcoming the code not running, the code throwing up an error. So if I execute this cell by pressing shift plus enter, it will not throw any error, even though I am not defining anything within the body of the class. So you can see this pass you can use wherever you want to use it as a placeholder. Then I will define let us now I will define the body of the class cars colon then there can be some common property for a class which are same for all instances of the class, that is all objects of the class. Say for example the number of wheels of all cars is 4, which is a common attribute of all cars. So it can be defined as a class attribute. Class attributes are generally defined just beneath the heading of the class. Say I am defining it as number wheels is equal to 4. I am passing on the constant 4. This is a class attribute or property. Now to define other properties which the objects of a class must have, other properties are instance attributes which all objects of a class must have, we will define a special method called def space, it is double underscore init, the short form of initiation, and again double underscore. Now such methods
which begin and end with double underscores are known as dunder methods. You will see such methods in case of classes. Now don't get confused with all these. You just remember that this is the way the class is defined, and you can define any class following the same procedure. So we are defining a special method, underscore double underscore init double underscore, and then the parameters are always, the first parameter is always self. It is actually a variable that references the class instance. Then the names of the class, the names of the instance attribute, then that is the properties which you think all objects of the class must have. Now you can say name, first make, then name, then color. So these are all the attributes, instance attributes that all objects of the class must have. Then in the body of this special method, self.make is make. What is happening is we are simply defining the special method. Um, then we will define one example of one method uh, which is within the one method, like we have seen the list method, string method. Similarly, this class of cars will have a method defined in it, and which can operate upon the objects which are instances of this class. So let us say it is defined, the name of the method is capacity, which takes a parameter n. But whenever we are defining a method inside the class, the first parameter will be self and then n followed by colon. Now what it the body of the this returns a string self dot make space self dot name has a capacity of okay, it returns this string f string. We have seen the f strings. These are the variables. So this is our definition. This is our class. Let us run it. Now let us instantiate an object. That can be done by typing the name of the class followed by parenthesis and the values that must be passed to the class. Now I am defining a instance of a class car1, which is an object which is defined using the name of the class cars, and we have to pass on the attributes make, name, and color. Now when you instantiate an object, Python creates a new instance and passes it to the first parameter self of this method. Now every time a new object is instantiated, this method is run, and the new object it tells Python about what the initial state of the object is. So you need not pass the self anything the self argument here. Then the make, let us say it is Suzuki Ciaz white. So I am passing, I am to for any I am defining an instance of this class cars by passing these attributes, instance attributes, uh, and then I will also create another instance of this class. Honda City. Let us say passing the color of magenta. So what we have done is we have instantiated two objects by typing the name of the class and then followed by the parenthesis and the values that must be passed on to the class for defining the objects. Let us execute this cell. Yeah. Now these two objects have been created. Now any attribute of any object, you can see the value of any attribute by simply typing the name of the object, then attribute, say what is the make, it is Suzuki. Similarly, car2 dot color, what is the color, that is attribute of the second car, the second object, that is magenta. So in this way you have created two objects which are instances of this class of cars with the real data by passing the real data. Here you are only creating a blueprint of the class without passing any data by a special method, and then we have also created a method which is operated upon the objects of this class. No, so let us also see how you can use this. Now let us see car1. Now you have defined a method. Now let us see if you can make use of tab complete here by typing dot and then press tab complete. So these are all the things which you have defined. Wheels is a class attribute which is common. Wheels, name, make, and color, these are all attributes, and capacity is the method which you have defined in your class. So you have defined your own data structure in Python, a simple data structure in Python, and you are able to apply the methods which you have defined, and you can get the values of the attributes. Now we have defined the attribute of wheels, which is a class attribute which is same for all instances or same for all objects. So you can see car1 dot wheels, which we have defined, it is the value is 4. Similarly, car2 dot wheels, the value will be again be 4. You can use the method capacity defined under the class defined in the class of cars. So how to distinguish between attribute and method? Method or function is always followed by parenthesis. So here the number of there is parameters to be passed is 1 other than self. So you can pass 5 as a param argument, and let us see what execute. You are calling the method capacity, then you are printing this return statement. The self dot make, that is car the Suzuki Ciaz has a capacity of 5. We are just simply printing this f string with variables passed inside the string. So this is just a simple example, just how to create a class and how to create instances of the class, that is objects, and how to um, define attributes, instance attributes, as well as how to define a method in the class. Then let's move forward. Let us come to error. I will write a heading here. To insert any cell above the first cell, get into navigation mode and press A. Now I will again create a heading here. Now here in the error handling, we already have seen the types of the errors which we encounter in Python. In case of runtime errors, we have said that reading the runtime error, the error message, it gives much insight into the what went wrong in your code. In error message, you can read the type of the error followed by colon and then more details about the error. And in the traceback, you can see where the line where the error has occurred, or the line where from where the function, any function was called, function having an error was called. So Python makes its best guess of where to look for solving the problem. Now this practice, you have to get used to reading errors on your own. In the beginning, it may seem very the traceback reading traceback may seem very confusing. However, it is very easy in case of Python, because you can have a look at the type of the error, you can have the description of the error also, and if it is a syntax error or any simple runtime error, you can easily rectify it. So we will intentionally create some errors and see what are the kinds of the errors which are generated normally. So if I try to apply the built-in function int to any string that is containing a non-numeric value, it will throw a value error. So you can see this is the traceback. It is very simple one-line code. This is the name of the error, value error, and this is the description of the error, invalid literal for int with base 10. So it was expecting a valid literal, that is a numeral with base 10. Instead, it has seen a character a string a. So it has thrown a value error. And you can see where the error has occurred in the line 1. It is showing. In case you have a big code, it will be very useful way to look inside the code. So that is value error is created in that way. Then we will see what is known as name error. Name errors are when you are defining, when you haven't defined any variable and then trying to call the variable, it will throw a name error. Say I am defining a new variable sum, which is 2 plus say x, where x is undefined. So it will throw a name error when you execute it. Name x is not defined. Then the type error is created when you are trying to operate upon two different data types. Say for example, you have a string 1 and you are adding an integer 2 to this string. So it will it was expecting after a string, Python is expecting a string plus another string for concatenation. However, it has received an integer, so it has thrown a type error. It can only, saying that the description of the error, you can see it can only concatenate string str and not int to str. It can only concatenate string to a string but not an integer. And where to look at, you have to look at the line number 1. So this is where the error is. So then you will have many other types of error, like if you are defining an function sum of integers and you forgot with the either colon or indentation. Let us see. Return, you have to pass two parameters, a comma b. Return a plus b. So it should throw an error because you are leaving out the colon. Let us see the kind of error. It is a syntax error, invalid syntax, because colon is missing. Suppose you are missing with indentation. Say you are defining a new variable c is equal to a plus b. We have seen that there should be consistency in indentation. Say you have 5 spaces, white spaces instead of 4 within the body of the function. Let us execute it. So it is still in the it is still throwing the error related to syntax. Yeah, so it is now showing an error. The name of the error is indentation error. It has expected consistent indentation inside the body of the function, but here it has unexpectedly the indent is not consistent. So where it has identified where the error has occurred. You can see in line 3. So this is line 1, line 2, line 3. If it is a big code, you can it will be very useful. So reading this trace back, this is the trace back. Reading this trace back, you can identify the line where error was lying. Error is caused, then the name of the error and the description of the error. Similarly, if we have a dictionary, most of the errors related to dictionary are key errors. By using the inbuilt method of dict, you are passing, let us say, tuple of tuples. It's a simple dictionary. Yeah, we are missing. So you can see this is again a type error. Um, the it was expecting a valid type of input inside the dict function, but we missed this comma, so it is throwing up a type error. And again, it so it is treating this as two parameters. So let us do one thing. Let us define tuple of tuples. Z is equal to this, and then pass Z inside. So it is a valid dictionary. Now if you try to call a key which has not been defined, in other cases it throws a name error. Here in case of dictionary, it the key is not defined, so it will give you here also it is giving you the name error. The name dictionary, the name is not dictionary 1. So yeah, this is a key error. So the key is not defined. The we haven't associated any value with the key C here. So it is giving a key error. So similarly, there will be zero division errors. Like if you are trying to divide any numeral by 0, it will give you a zero division error. Division by 0 is not allowed. And it will give you an overflow error if you are defining any integer power, a big number which is overflowing, which has a very high value. It will give you an overflow error. Then you will have an Unicode error if you are trying to decode an code say if you are if the coding is done like the characters coding is done in UTF-8, but you are trying to decode it using ASCII, it will throw an Unicode error. uh, so these are the various types of the errors which you can come across. So the takeaway here is that in Python, it is very easy to identify the name of the error and description of the error and the trace back, especially if it is a big code. You will also find the line where the error is occurring, or from where the error is initiated through a call of a function or some other way. So make it a practice to read error messages and trace back so that you can handle these errors in a better way. Then let us see what is known as try and accept statements. So now in case you want to have the code running without throwing up the error, suppose you know the probability of getting the error, the probability of getting an exception before execution. You can within your code you can you can handle it in a better way. Like the see, let us see the example. Try, you can try is a keyword, so it is highlighted in green here. Try colon the statement with the indentation, it will automatically take. Let us take an input of number. Number is equal to user defined input, which we have seen earlier. Let us also pass a prompt, enter a number. Okay. Now, and we have also seen that input returns anything within anything as a string. Even if a number is entered by the user, it will be written as a string. So you have to convert it. Of string number entered is here. There is no need to convert because in f string everything you need not convert a string into an integer. Otherwise number entered is this one. Or except, this is the block of the code with try statement, and then except value error. That was not a number. So let us try to run this. So here what we are doing is we are trying to handle exceptions using this try and accept statements. So whenever there is no exception, only the try block will be executed. When there is an exception, but this print statement will not throw any exception anyway. Let us say int of number, then only we will get an exception. So we will get a value error if we are trying to convert a string of characters, a string of non-numerals using inbuilt method. So in case what we are doing is under try statement, this block of the code, we are asking the user to enter a number by using the input method, and input we always know it converts it returns the value entered as a string. Whether if we are entering a number, it will return the string of the number. However, you can convert that string using int method. If you pass the string of 2 here, it will be converted into an integer 2. But however, if you are passing a string of a, it will not be able to convert and it will throw an value error. So what happens in case of value error, it raises an exception. It will create an error message. So to avoid error message, what we are doing is we are defining the keyword except, and we are saying we want to manage this value error message by printing that was not a number. Instead of this throwing the error, it will print that was not a number. Let us execute it. So let us it is asking the prompt asking the user to enter a number. Now I will enter any integer. So if I am passing 5, because it is a number, no exception will be raised and the except block will not be executed. You have to print statement. Okay, enter a number 5 and then I am executing. So when I executed, it is printing the number 5. So what is happening is when I am entering a number 5, this input of 5 it will convert it into a string of 5. And when we are in the it is actually converting the string of 5 into an integer 5 with this, and it is printing 5 here. So the try block is being executed because no exception has been raised. It will not go to this except block. However, you know the probability of user entering a non-numeral string, a string which doesn't contain numeral, which is not which will throw a value error. Definitely, it will throw a value error if you are passing on a word, a string of words instead of an integer. So in that case, instead of throwing error, it will print this statement. So let us also see that. So I am passing hello. So as you can see, when we are passing hello, this block will raise a value error when the input converts hello to hello string, and the int built-in function, when it try to operate upon hello string, it will throw the value error. So exception is raised. In normal cases, what happens is, if you don't have this except block, it will simply throw an try is always associated with except block, so it is throwing a syntax error. Otherwise, what happens is, without try, if you execute it, it will simply throw value error. It will simply throw the value error invalid literal for int with base 10. I am passing a string, some string. It will because this block throws an exception, it will implement the except block, and this statement will be printed. So that's about handling. Just as you had only one except block, you can have multiple except block. You can also include, you can think of probable errors which can be generated with your the code. Like here we are able to guess it will throw a value error. Similarly, you can expect, you can imagine, you can think of all the possible errors, and you can have multiple except blocks following the try. So as long as there is no exception, the actual code will be executed, and whenever there is an exception, the corresponding except block will be executed. Let us start with file handling in Python. Files, as we know, are organized in our system in a hierarchy of folders. And every running program has a current working directory or present working directory. As in our case, we are operating in a folder, in the my home folder is where I have installed Anaconda 3 folder, that is in C drive users and the username, the folder in the username. Then I have created a subfolder of Python WRM and notebook subfolder, and where I am operating. So this is my present working directory or current working directory. And the file system manages communication between the computer and the storage, physical storage devices. We need not know how it is done, but we just need to know that there is a file system, and we need to know how to manage the file paths. So at the top of these file system, there is a hierarchy of directories. At the top, there is a root directory. However, in Windows, there is no unique root directory. In each drive in Windows has a separate file system starting from the name of the drive. Like C drive, it starts from the C, and D drive, it starts from D. Whereas in other operating systems, there are unique root directories. And one more thing which you need to know is whenever we are saving in the present working directory, we are saving the notebooks by giving the relative path, by giving the name, as well as by saving, when we are saving it, we are only giving a relative path to the notebook directory. See, as it says, enter a notebook path relative to notebook directory. So we can also even operate using absolute paths. But generally, it is convenient to use relative paths when you are operating within a folder. So there are and then the path address in Windows, if you see, it makes use of backslash character, which is interpreted differently by Python. As a Python sees backslash character as an escape sequence, as a special character. So there are variations across operating systems in handling file paths to make for better handling. Python version 3.4 and higher versions have they have come up with a module pathlib. This Python, when you are installing Python, its standard library has many modules. Like we have seen the module math for using mathematical functions. Similarly, we have a module called pathlib, which has a class path and associated functions, methods. Any instance of the path class in the pathlib module, it will be a new path object. So we will see how to create a new path object. We can create it by using a string. For example, let me create the heading of the so I have copied the path to this home directory. Now to create a new path object using pathlib module, let us first import pathlib just as we had imported math module for making use of the methods associated mathematical functions. So this is part of the standard Python library. Unlike many other third-party modules which we have installed in the beginning, like GeoPandas, Rastereo, Pandas, they are third-party packages. They are external. They are part of the external library. Whereas this pathlib is a part of the Python standard library. Um, So this pathlib contains a class called path to represent the file paths. So to create a new file path object, you can create it by passing the string fp is equal to within the string. However, because of the presence of backslash characters, we can turn our string into a raw string by suffixing with r. So whenever you are passing a string, you make it a practice when you are passing a path, you make it a practice to suffix your path string with r, which converts it into a raw string that will help us in getting over this Python interpreting the backslash character differently. Or you can use forward slash character, but the preferable way is using raw strings. So this will create a path object. You can check the type of fp, which is actually a string, as we haven't used the method, any method inside pathlib. We will do that. So one way is by this string. Now we will make use of the methods which are inside the path class. One method is path.home and another is path.cwd, that is stands for current working directory. Now if I am assigning cwd to path, which is the class dot, you can have a look at available function methods in the class path inside this module pathlib by pressing the period and by pressing the tab key, which will display the methods. Sorry, I think I have to. So for the Jupyter notebook, it doesn't know about path class unless you make use of the name of the module. So pathlib dot path dot. Now you should be able to see the methods which are there in this class path inside pathlib module. There is a method cwd here, which should return the current working directory. We can print cwd. So it returns a path object, Windows path, with the string pointing to your current working directory, which is the notebook subfolder of Python WRM folder of the user, where I have installed Anaconda 3 folder. So this is one thing, and you can also similarly get your home directory with the method. Again, I will press dot and press tab key, and I will select the home method, path.home method, and I will print home, which again creates a path object, Windows path, which is my home directory. You can also a file path can also be created using the / operator. Making use of / operator. Here I am making use of methods inside path class in pathlib. And here I am just passing the string. So here what you do is, on either side of the on the left side of the this forward operator, / operator, you give a path object. Say I am providing home, which is my home directory, and then you provide a string. I am assigning it to fp2, which is home, then / operator, then I will provide a string. In my home directory, I will point out to this directory Python WRM, say. Then it will create a new path object. Let us print that. So it again creates a Windows path, a new path object, C users comp 109, that is the home folder, home, that is again a path object, and then you are you are passing a string, which is the name of the directory. Similarly, you can pass on the name of an individual file, or you can even pass another path object. Then it will combine the / operator will combine and create a new path object. Then there are some attributes, if you want to see the list of directories in this file path, all the list of directories, the parent directories, let us say fp2 dot parents attribute. Because it is an attribute, we will not use parenthesis. Let us see what it prints. Yes, we have to, it is printing a list of all parent directories starting from, for this file path. There are, yeah, as you can see, in a hierarchical fashion, it has printed list of parent directories. Parent, this is path objects. This is a list of path objects starting from the root directory, then C users, then this is my home directory, within which I have my file path. So just to tell you, just to make aware of the various attributes and methods which are available, if I am using parent attribute, it will print the immediate parent, that is C uses comp 109. To get the name of the directory or the file, I can use the attribute name, which is Python WRM. So these are the some useful attributes and methods. Now we can see whether the present path exists or not using exists method. fp2.exist, because it exists, physically exists on your system, it will return true. Whether it is a file, no, it is actually a directory. The file path fp2 is pointing to a directory or folder. So if we use this method isFile, it should turn false. Whereas if I make use of isDirectory method, isdir method, it should return true. So to create a new directory, you can define a variable name new directory. In fp2 dot, let us say we have a function called mkdir make, which is a short form for make directory, to create a new directory which is not present or which doesn't exist. And then you can pass the name. Simply say new folder. Let us execute this. It gives an error because we have it is not the way you can create a new directory. You have to first define the file path, and then you make use of the function mkdir. So we have the file path fp2, which is pointing to the directory python wrm. And if you want to create a new directory inside, let us say we use / operator, which is, this is the path object, then / operator, and then let us say you want to create a new directory called new folder. First you have to define the file path, and then you have to make use of tab completion. You can make use of the method mkdir within parenthesis, and let us try to execute this. So it is running. Let us check whether a new directory has been created within. Yes, it has just been created, a new folder. So this way you can create new directories by using path.mkdir method. Let us try to create a new file. I will define a new file path fp3 is, say I have created a new directory new _dir, Then I will use the forward slash operator, and then I will try to create a text file file1, and execute it. Let us check the contents of the new folder. So no new file has been created. You can check the existence of the file by using the method. So this fp3 points out to a text file. We have defined the file path. You can check dot exists method. No, it doesn't exist yet. We'll see how to create. Then you can check whether it is a file using isFile method. It is not a means it has not yet been created, so it doesn't exist. Now let us try to create the file using another method called touch method. uh, you have only created the file path. Now you have to create the actual file. fp3 dot, let us check the methods which are available. There is a method called touch. Let us see. So whenever you are in any you want any help, you can immediately, you can always use this option. You can use tab completion to check the available options, and then you can use help to check what it actually means. So this will create the file with the given access mode if it doesn't exist. So the file doesn't exist, so this method will create a new file with the access mode. The mode, there are various modes for reading and writing files, which we will see. First, let us try to run this fp3 touch method, which should create a text file. Yes, in Python WRM folder a new folder has been created, and in this a new file, which is a text file, has been created. Now you can check whether fp3 exists, the file exists at this file path. Yes, it exists. And fp3, if it is a file, you can check. Yes, it is returning true in both cases. So we have created a new file. There is one more thing which we can have a look at. Suppose you are giving a file path of a I am defining a new path object fp4, which is fp2 new directory which points out to the new folder, and the new folder doesn't have any directory yet. However, I am defining a file path new directory slash forward slash operator, again a new folder inside new folder, or let us say a folder A, and I am defining fp5 as fp4 forward slash operator. So I haven't yet created folder a underscore a, but I am defining a subfolder of folder slash a, the path to fp to this. Now if I try to create using mkdir, so I have defined the file path, and if I am trying to create a subfolder without creating the parent folder, what happens is it will return as expected, it returns a error which says that the system cannot find the path specified because the folder A doesn't exist. Now this mkdir method has these parameters which you can make use of, like you can the default values of parents and exist okay are false. Now making by defining them to be true, it has I have turned the default I have overwritten the default parameter parents to true, and made use of mkdir method. Let us check whether a new folder has been created. Yes, the folder A has also been created, and subfolder B folder B has also been created by turning this on. There are some more methods which are associated with the path class in the pathlib module for copying files or folders from source folder to a destination folder, and then deletion of any file, which we will not get into them. You just need to know that there is a inside Python standard library there is a module called pathlib which can be used for file path handling across the operating systems. For reading and writing files, we will be using inbuilt functions of read and write, so we will not be requiring any module as such. However, for file and directory manipulations, you will be needing either this or there is another module other than pathlib. There is one more module, operating system OS module, which has some useful functionalities. Let us quickly see it. I will import OS using this command import OS, and let us have a check at the methods which are available in this OS dot and press the tab key. You will have a look at these are the various functions or methods which are available. Um, you can make use of get cwd to get current working directory, which will point out to the same folder where you are saving your notebooks, that is C users comp 19 python wr C users comp 109 python wrm, then notebooks subfolder. So now if you want to change the working directory, you can do that using this method chdir, and at any time you can make use of help function to know what it does. So it changes the current working directory to a specified path. So let us specify a path chdir. You pass it as a string. We will pass it as a raw string. Let us check. I will take I will specify a folder which is outside C directory. I am passing it here. Then you execute the cell. Now your if you run os.get cwd, the current working directory, your working directory has been changed to D and D drive reference material. So, and there are a few other methods, like you can just as you have you can create you can make directory, you can change directory, you can list all the files in this working directory by this method os.list.dir, which will create a list of all the files which are available in this folder. Incidentally, all these files are PDF files. Let us create a dummy text file. And let us execute it again. So you have an additional file, one.txt file. So you can get the list of files in the directory present working directory. You can also check the existence of some folder or check the existence of some file. You can check whether it is a directory or whether it is a file. Like for example, whether the current we can join the you can create a file path using this os dot path dot join, which is, let us say you are assigning your I think we have reached up to FP5. Okay, FP6 file path 6. I am defining, I am assigning it to the current working directory, which is in a different folder other than C, and then I am using this let us first execute it and also print FP6, which is the same as current working directory, and we can check whether it is a directory or whether it is a path using this function os.path is dir. You pass on the file path, it is true. You can check whether it is a file. You have similar functions in pathlib module. It will turn false. Then you can create a new directory uh, using this mkdir. Let us see if it creates a new folder. Let us check. Yes, a new folder has been created and a new empty folder has been created in the present working directory with mkdir method. You can also join the paths like os dot path dot join. You give fp6 and then I have created a dummy file file1.txt. We can join this and assign it to fp7. Let us run it and then print fp7. So you can have a file path to the text file file1.txt. Then you can check fp7 whether it is a file. os.path is file fp7. It will return true, and if you check whether it is directory, it will return false. So that is about OS module in quickly. We will be using os.path.join this function often for creating file paths in our scripts. Then there is one more module called glob module, glob. You can import it as import glob module. You can execute it and then you can check the methods which are available. Glob dot magic check bytes. It is a very useful module for, and there is a regular expressions also are there. It is a very useful module for searching files and folders. Just to give you how it works, let us say what is the current working directory as of now. os.getcwd. It is D reference material. Fine. Now D reference material has one folder, 4 PDF files and 1 text file. It is a simple folder. If you have a very big folder with many files also, it will be very useful. Then it will be very useful. Now let us say I want to isolate I want to list all the PDF files. You can simply pass a string asterisk, which stand for general anything dot PDF. If I pass this, it will list out glob. It will list out all the PDF files in the present directory. As you expected, there are 4 files, PDF files, and it has printed a list of these PDF files, which is a list of strings. Similarly, suppose you want to have text files. .txt glob txt. It will print one text file which is there. Suppose you want to even print the files which are existing in a subfolder, then you can use glob.
You can even print all the files within this current directory by passing asterisk dot asterisk, which means all the files will be printed. No. No, this is not valid. No, 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 no. I'm always missing the second glob. I think it is not a valid syntax. Now, what I was trying to say is we can anyway, for listing out all the files, we have list dir os.list dir method available. If you want to print the files within a subdirectory also, for example, let me copy one PDF file inside this new folder, which is inside the current working directory D reference material. Now I will run glob dot glob. I will pass the string which is slash star asterisk slash asterisk dot pdf, which means from the current directory I am getting into the subfolder and I am trying to print what all PDF files are there. Yes, so it is printing the subfolder name, that is new folder, and it is also printing the PDF file which is within the subdirectory. So even it will search the files and folders within the subdirectory also. So I think that is enough for file path handling, and we have seen important modules, useful modules, pathlib, OS and glob. Now we will see how to uh, read and write files using the inbuilt methods in Python. Um, there are the built-in methods for reading and writing text files and also CSV files, which is by line we can do by iteration. Now we will be seeing the pandas package, where we will be dealing with high level tools for reading data files. However, this one writing by line in a reading line by line in in an iteration, it is a basic method making use of built-in methods, which is also you must be aware. Uh, um, so it is very similar to reading of books. Whenever you want to read any book, you will open the book, you will read it, and then you will close it. And if it is a book, if it is a diary, if you open a book, you open the diary, you make an entry, and then you close it. So similarly, whenever you are handling files, you have to open the file, then read or write mode or append mode. There are modes of operation. Then you have to close the file. Um, Without not closing the file may lead to sometimes creation of bugs, which is not advisable. So, and what if someone forgets to close the file? Nothing happens, but it is advisable to close the file after writing or reading. And if you are operating with the keyword with file open, it automatically closes the file. We will see both this, and also we will see pickling module, which will be useful in handling files. So let us try to open a file. We have already created one text file in this. Let us try to open it in D reference material and file 1.
So I make use of open built-in method to create a file object f by passing on I think I can, because the current working directory is uh, dereference material. I think I can simply pass on file1, the relative path. File1.txt. I am opening the file in read mode. So it is not throwing any error, means we are giving the right path as well as we are giving the mode also correct. If in case the file doesn't exist and if you are trying to open it in read mode, it will throw an error. Let us also see that. Let us say I am saying open file text2 and in the read mode. So it will throw a file not found error. No such file or directory file2.txt. Anyway, now let us try to write in file1. However, if you are opening file2 in write mode, it will not throw file not found error. It will instead it will create the file even if it doesn't exist. So it hasn't given any error, and if you check the directory, a new text file file2 has been created. So let us write something inside the file. If there is, we have to use write method f dot. Now you can check the methods which are available by with this file object. Whenever you are opening a file and assigning it to a variable f, the type of f also you can check. Type of f, it is a text input output wrapper. It is actually a file object. Then you can write f dot and type tab to check the methods which are available. So let us check write f dot write, and let me simply give an input line 1. Let us execute it. It returns value 5. It is actually the number of characters that you are writing. As you can see, the string I am writing which I have written has 5 characters, so it prints 5. And you can check the file2. I think we are writing it in file2. Nothing has been written over there. Unless you close the file, nothing will be ultimately written over there. Let us also write one more line, which is line 2, and then execute it. Again it gives an output of 5. Then let us close the file, f.close, using f.close method, and let us check whether anything is written here. Yes, something is written over here. Let us try to read it using f.read method. You no, we have to, because we have closed, you have to again open the file by passing on the path. Here you can give simply file2.txt. We are in a different directory. We are in the same directory, file.txt, and open it in read mode, which is R. what has happened is file2.txt. Let us do one thing. F1 I am okay. Now I have opened the file using by assigning it to F1, which is a new file object. Now you can read what is inside the text file using text is equal to f1 dot read method, and you can print text, which will print what is written over in the file text2. We have actually written two lines, but so it has been printed next, means it has been written without any space in between. So you can try writing using a new line character. This read method can also take the number of characters to be read as an parameter. If I am passing 5 is the number of the characters that are to be read from the file f2 text to file2 dot text, which is referred by the file object f1, and if I am printing text again, it is printing an empty string, because it has, once it started reading the file, it has reached the end of reading 2. So if you still pass if you still want try to read the file, it will only throw the empty strings after 2. You have to first close the file and try to again open it. F2 equal to then you can say you want to read only 5 characters and save it in text 1, and then you want to print text 1. So as you can see, only 5 lines from the file have been printed, and when we get to the end of the file, as we have seen, it will return an empty string. So let us write into text 1 file f3 is open file1.txt in write mode, open write mode, and f3 dot write, just as we have done earlier, line 1, and print backslash character and n. That
So this backslash character is counted as one single character. So it is saved as a single character. So we have an output of 6. Then let us try to write another line. Line 2, again backslash n. Now let us try to check what is written in the corresponding file f1. Again we have to close the file, f3.close. So you can see that lines 1 and line 2 are written in separate lines. So there is another method for reading lines, the read line method. Similarly, the write line method is there, read lines method is there. So read line method will read one line at a time. So first you have to open f4 is equal to open file1.txt in read mode, f4 dot read line method. You save it in text3 and you print text3. It will return line 1 along with the line new line character backslash n. So the control has reached up to the end of the new line character. If we try to read further by passing on f4.readLines function, which would have read all the lines at one go, it will read the remaining lines in the file. And this read lines functions will give the list of lines, list of strings, considering each line as a single element. We can close f4. We can try again to use the read lines method by opening file1.txt in the read mode. Now we want to make use of the read lines method, f5.readLines method. Let us see what it returns. It returns again, it returns a string, a list of strings with each string comprising of the line, each line. So when you have a big file having multiple lines, big text file having multiple lines, you can easily generate a list of those lines using this method, read lines method, which will be very useful because you can anyway once you have the list of all the lines, you can access any element of the list using the methods which we have seen, the list slicing or list indexing and slicing methods. You can read any element or any line and you can access the information contained in any line. Suppose you have a data of which is saved in the form of text file. Data, it could be rainfall data, it could be discharge data, anything.
And if you are accessing if you are opening the file and you are using read line in the read mode, and then you are making use of this read lines method, you will be generating a list of all the lines in the form of string. Then you have to further process the list for getting the any particular data. For example, corresponding station in if a value of a station corresponds to uh, say in each line there is daily data of particular station at some position, say this position NE position. Let us assume that it refers to a actual data of rainfall of a particular station every day, and this is daily data which is getting added in every new line. So NE here refers to the rainfall of that particular station on a particular day. NE here in the second line refers to the rainfall of that same station for the next day, and so on. If you have a line, if you have a big text file, so you can access it and you can prepare a new file with the data containing only the rainfall data of that particular station, and then you can do any kind of analysis. So this is about file handling in Python. We won't be requiring much about this because we won't be unless you have a text file, big text file, and you want to which is has much which has important data in it. We will be not requiring this. We will be using pandas in case if your file data file is in CSV or XLS, that is Excel format. Finally, let us have also have a look at CSV module, which is part of the Python standard library, uh, which is used for reading and writing CSV files. CSV files are comma separated value files, which is a common file format which you can come across while dealing with hydrometeorological data as well as geospatial data, where you have a value in each row. The values are separated by commas, which are comma is a delimiter here. Similarly, there can be semicolon as a delimiter, there can be space as a delimiter, there can be tab as a delimiter. Then they are known as tab separated value format files, TSV files. um, CSV files has some important functionalities. CSV module has some important functionalities which we can make use of. However, at the same time, CSV file and Excel files are data files are can be used as input to the pandas data frame structures, which is more efficient and more useful way for data manipulation, data cleaning, data analysis, data visualization. We will just have a look at how to make use of the important functions in CSV module. We will work with a CSV file which is provided to you, the gauge discharge data in the CSV format, where you will have the data of in uh, data of 15 more than 15 years, I think 16 years data starting from January 2005 to 31st December 2015, where the first row is the day of the day, the date of the day. Then the second row is the data type, which is either HZS. Most of the time it is HZS or HHS. HZS refers to the absolute gauge data, whereas HHS refers to the data with reference to mean sea level. Then in the third column you have the mean gauge in meters, absolute gauge, and in the fourth column you have discharge in Qmex, which is either observed or computed, which is as per the last column. Sometimes it may be difficult to venture into the river, like in when the river is in flood. So then that time, instead of measuring discharge using current meters and calculating by area velocity method, they observe the gauge, and from the rating curve they compute the discharge. Computed discharge is referred by C, whereas observed discharge is referred by O.
So that is the format of the gauge discharge data which is provided. Let us try to read the data using the CSV form module functions. That will first initialize the module by importing CSV. Then you can have a look at the methods which are available by typing CSV dot and pressing the tab key. There are some important methods like reader, dict writer, and reader and writer, which we will have a look. Before going it, we have to define the file path. We can define the file path 1. I will use the pathlib dot path function, which is home. So my home directory is C folder. My file is in notebooks folder, whereas my home directory is up to this folder. I have to add to the path, which I can do by various methods. I can even use os.path.join method, or I can use this forward slash and then the name of directory python wrm and then slash the name of or I can simply say, I could have said path lib.path dot current working directory. However, I just wanted to explore this whether we are getting it right. So let us print file path 1. So it has created a file path object to referring to the notebooks folder. So let us make use of two CSV modules, csv.reader, two CSV module methods, csv.reader method and csv.dictReader method. DICT stands for short form of dictionary. This dict, both of them read each row of the CSV file, and they create a list and dictionary respectively, containing the values of the CSV file. The dict reader is more useful as it reads each row and creates a dictionary with column names as a key and column values as the value. Now we have the file path referring to the directory containing the gauge discharge data. Let us create a file path for the file fp underscore gd underscore data, which is file path 1 forward slash operator. The name of the data gauge discharge data file, take care of uppercase letters. Have a look at the name of the file and then try to print the file path object if it is getting created. Yes, it is you have now the file path object referring to the CSV file. Now in the first method we make use of gauge discharge the first method we make use of csv.reader file reader method, sorry. We as it creates a list of values, we create initially a empty list, daily discharge data. Then we make use of we have talked about opening and closing of files and why it was necessary to close the files to avoid some creation of some bugs. So when you are opening the file using this keyword with so and so file opened as so and so,
that will, whenever you execute the file, whenever you execute that code block of the code, it will automatically closes the file after it runs the after finishing the execution. So there is no need for you to again close the file. So we will make use of this keyword with the same function open. Then I will the first argument is the file path, which is fp underscore gd underscore data. Then mode is read mode, and then encoding is UTF-8. Now when a text file is written, and the characters which we type are converted into bytes, and that is known as encoding. And whenever it is read again and trying to read the values and type the values, it is decoded back to the text. So it is this encoding decoding is done in four ways: ASCII, then UTF-8, UTF-16, UTF-32. Now, for example, if you are decoding using ASCII, it may not be able to because UTF-8 can read more values than ASCII. If you are trying to decode an UTF-8 coded file using ASCII, that may not be able to. Sometimes it may not be able to read the values fully. So, however, the other way, the UTF-8 can be used for decoding the ASCII coded encoded file as it reads all values. So that is about encoding and decoding, which is not much important unless you are getting some error. By default, you can take UTF-8. So with open the file path, mode, and encoding as f colon, then the block of the code will be indented below this header. We will define reader is equal to csv dot. You can have a look at the functions available by pressing tab. So dict reader we will be having a look after this. Then we are selecting reader. Sorry for that. So we are passing the opened file into csv.read as an argument to csv.reader method. You can check what has been created. Reader is a csv.reader object. You can print each row by reading the row. For row in reader, you can say print row. So this csv.reader method has read each row of the this file, and it has made it has created a csv.reader object, and we are trying to read what each row contained in the csv.reader. It is a different object. It is not a list, but however we are trying to make a list out of it. So let us try. It is giving a value error, the input output operation on a closed file. Okay, the file has been closed because as I said in the beginning, whenever we are using the with keyword, the file after its execution of the block of the code
this block of the code, the file gets closed automatically, so you are unable to print the values. Now to instead, what we can do is we can make it part of this block of the code only. For row in reader, for rows in read for row in reader, print row. So let us try to run this cell. So you have this list of values pertaining to each day, the day, then the type, data type, the gauge, discharge, and whether it is observed or computed discharge. uh, it has been included in a list. Therefore we have a list. Even the header file has become a list. So this is 11 years daily discharge data. However, you can see this this has got printed because of something to do with the encoding part. Now whenever you see such an object, you can here UF EFF day, it has a byte order, it has something to do with byte order, which can be rectified by changing the encoding to UTF-8-SIG. I am again running it. So you have I got it removed. So you have the first row, first list in the list, and the first item of the list has the headers, and the remaining items we have sequentially the daily data. So you can however, this is not actually it is a reader, CSV reader object. It is not actually a list of lists. And the values, the gauge and discharge values are also they have also become strings. So you have to reprocess this CSV reader object to get the floats from the strings for further use in your for further analysis. So this is how you can make use of CSV.reader method. Let us go further to using the CSV.dictReader method. So we'll write a similar code with file and we'll copy this. The only change that I am changing the method dictReader, and I am executing it. So you have dictionary, each row being converted into a dictionary. And the keys are as you can see, the header row values have become the keys. These have become the keys for each of the dictionary. Day, date, data type, mean, gauge, and discharge, and observed or computed and data. So this dict reader object is much more useful than the dict the normal CSV.reader object. You can create a dictionary of dictionaries out of this, and you can make use for data analysis. However, again, the values of mean gauge and mean discharge are again printed as strings, uh, whereas other data type and observed or computed data, they are they are of not much use to us. And another is day. The date is also printed as a string, which we can convert into date time object. We will see date time um, methods afterwards. So let us write a simple user-defined function for converting these strings into floats for each of the dictionary. You can create a user-defined function which starts with the keyword def, str to underscore float, which takes row as an input as a parameter, and then inside you have to convert two keys, values corresponding to two keys into floats. So row, you can copy this key, you can convert it into float row. This similarly you can convert row discharge qmax. Float and again you get back the row. So this is a user defined function which takes one row at a time and converts the values associated with these keys, mean, gauge, to floats, these two keys, gauge as well as discharge, and it returns the row again. Now let us run the same. So we have defined this function, we will execute it. So the function is defined, we can make use of this function. Let us copy this code. Here in this case, you have to print the row after processing by the user defined method string to float. You can execute it. So it has, again we have got dictionaries of data, daily data, where the gauge and the discharge data have been converted from strings to floats. Now we have a series of dictionaries. From this can be a starting point for further analysis, making, because dictionaries are very amenable for data analysis, and each value is identified by the key, corresponding key. You can one can further think of making use of this data for further analysis. However, we we will not be using CSV module and other modules which we have seen for our purpose. We will be using the third-party package, that is Pandas, which we have downloaded, which we have installed on our systems, which provides an efficient structure called data frame, which we will see.
which can be used, and you can input your CSV or XLS data into the data frame, and it is very efficient and very fast and very useful for data manipulation, handling, analysis and visualization purposes. We will see it in the next session.
So in today's session, we have seen object-oriented programming in Python. Then we have seen error handling in Python and file handling in Python. We have seen some important modules which are part of Python standard library like pathlib, OS, GLOB for file handling, file path handling, and then we have seen CSV module which is used for reading and writing of CSV files. In the next session, we will start working with pandas. Thank you very much.